Hello everyone, myself Sama Sheikh. I'm a fourth year PhD student at IIT Bombay under Professor Santosh J. Bharpure, and I am a TA of NPTEL course which is entitled as Principles of Organic Synthesis, and the course instructor is Professor Punya Murthy from IIT Guwahati. So we have done this course till week 8 and today is week 9. So in week 9 we are going to discuss the classes of Punyamurthy sir on YouTube, which is a week 9 classes. So the lecture number 17 and 18. So here we are going to discuss some name reaction. So we'll see the mechanism and problem based on those name reactions. So let's start today's session. So predict the major product of the following reaction. So here we have given the two starting material substrates, and the on arrow we can see that butyl lithium is given in THF, right? So what is the mechanism here? So this reaction is comes under the name reaction Bovilt aldehyde synthesis. I hope many of you know about the mechanism, but those who don't know, we will solve it here. Okay. So as you can see, magnesium is given here in zero state, right? So this in this reaction we have magnesium, but all of you know that lithium also uh, done the magnesium job, right? So how will the mechanism will follow here? So if suppose we have any hello, am I audible to you? Okay. So here we have halide, right? Hydrogen and halogen and this group, right? So all of you know that butyl lithium first of all do the halogen exchange reaction, undergo halogen exchange reaction, right? So if it will undergo halogen exchange reaction, what will happen? It will form this type of intermediate, right? I hope all of you are clear till here. Then what's the next? So here you can see that magnesium is getting inserted between halogen and alkyl chain. But here because lithium has one valency and in butyl lithium condition halogen exchange reaction is taking place. So we will get this as an intermediate. Now what will be the second step? We have here amide, right? Aldehyde amide. Here amide group. Here also we have amide group. So in this case, if you see the actual mechanism of Bovilt aldehyde synthesis, here you can see that this oxygen, so this is a aldehyde and this is carbonyl center, correct? So this is the electrophilic center and we have Grignard reagent here, right? So R minus will attack on this center and it will get open and same as Grignard reaction, it will happen here. So as we have discussed in earlier classes, then how the lithium organolithium compound attack on a carbonyl centers, right? So we have detailed discussion video on that topic. You can go and check about organolithium reaction, organosilicon, organozinc, everything I have discussed. Okay, so here we have organolithium compound, correct? Organolithium. So next it will undergo nucleophilic addition on this amide group, correct? So here I will write in same manner, so it will be easy for you to understand. So suppose we have here this group, correct, and here we have carbonyl center because this center is going to attack. Oh, sorry, I will write here intermediate. Sorry, this is another reagent, not intermediate. Okay, so this is going to attack here. It will get open, and here we get OLI. Okay, and here our NMe group will remain as it is, and the attacking group is our R. What is R? This group only. Okay, okay. So here we have H. H was that initial. All of you got this intermediate. After this one, what will be the next step? What will be the next step? Hydrolysis, same as it is. So after the hydrolysis, I have discussed this thing also. Water will attack and how this will get protonated and this NMe twice group will eliminate. Okay. So go and watch previous videos for detailed mechanism, but here remember hydrolysis is taking place to give the corresponding aldehyde. So this lone pair will push it and it will leave this group. Okay, so here we will get this as a product. So this Butyl-aldehyde synthesis reaction is same. Instead of magnesium we have used here lithium reagent. Okay, so organo magnesium is not here in this case, it is organolithium reaction, CH. So the correct option here is option number 3. Next question, predict the major product of the following reaction. So you can see on arrow we have copper chloride, sodium methoxide, and solvent is methanol and DMF. So whenever you have base and this type of reagent, you should understood whenever we have metal here, so most of the time like palladium, mostly the palladium gives a hint of coupling reactions. So here this is the Ullmann reaction. So copper is given here on arrow. So how many of you are heard about this Ullmann reaction? Anyone? Okay, no problem. We are going to discuss this mechanism today. So first of all of you know that we have here copper chloride and this is the starting substrate. So we know that whenever we have any halide, organohalide molecule, it will with copper it will undergo Ullmann reaction. So the mechanism will follow here oxidation addition. Okay, so on copper oxidative addition will takes place. So oxidative, after the oxidative addition we will get this as an intermediate. So in our case, instead of this one we have this whole group. I will write here. Why between I only, F not? Because this is a good living group and it's bulky also. The size matters here, and that's why whenever you have two halides halogen atom on the same ring, always iodine react fast because of good living group and the size also. So iodine reactivity is high, then Br, then Cl, then F. Remember this sequence. It follows this one only. Okay, so let's talk about the mechanism now. So on copper, oxidative addition is taking place, and we have already have here copper chloride. So copper here is there in +3 oxidation state, intermediate. I'm talking about the intermediate. Okay. So after this one, we have base, right? So base will extract the proton. So from where it will extract the proton? Can you guess here? So you can see we have sodium methoxide, right? So here, yeah, because sodium methoxide is already base, but here it is not acting as a base, it is acting as a nucleophile. So OMe, because in here we can see that OMe magnus is getting attached. So OMe will attack on this one, and transmetallation will takes place. Okay, if you will see that static, transmetallation will takes place, and we will get here copper. I am writing this whole group as R and OMe. Okay. Or X, better I will write X. After this one, reductive elimination will takes place to give the corresponding product. So here you can see that copper insertion is taking place. Then the this will this will again undergo oxidative addition and with another molecule, but in this case we have sodium methoxide, right? So sodium methoxide will attack on this one, and we will get, after reductive elimination, we will get our desired product. So this ring is getting attached, but in this case our OMe is getting attached. So reductive elimination will give you ROMe. So here you can see that OMe group is coming instead of halogen. OMe group. So the correct option is this one. If So again the next question is, predict the major product of the following reaction. So here Stephen's Castro coupling reaction is this one. So in this case we have copper reagent and halogen haloalkane. Okay, haloaryl. So here you can see that in this case, the reaction is believed to proceed via Ford-Center transition stage. So we have this our starting material substrate, and then alkyl substituted metal ion. Okay, so here we have copper reagent like this one, and then next what will happen, it will form Ford-centered transition state. So in this case it will get attached to this one. I will make it here how the transition state will look like. This one, this way. Okay, so what will happen, this whole group will get attached here, right? So it will get attached here like this way. One, two, three, one, two, three. Okay, one more carbon. Now this is the intermediate we will get here. Now we are again refluxing the reaction, and it will undergo a hydroalkoxylation reaction. So 6-endo-dig hydroalkoxylation. Why 6-endo-dig hydroalkoxylation? Because this oxygen will attack over here and double bond is coming inside the ring. So whenever this type of reaction is taking place in triple bond via heteroatom, that time 6-endo-dig or 5-endo-dig, depending on the ring size, the name reaction is given. Okay, so hydroalkoxylation because it's undergoing a hydroalkoxylation reaction, that's why. So after this one we will get the this type of intermediate, and protonation will takes place to give the corresponding product. So the correct answer is option number 4. Okay. Next one is predict the major product of the following reaction. So Chichi-Babin reaction, this is the type, this is the example of Chichi-Babin reaction. What happened in Chichi-Babin reaction? We have pyridine, right? So instead of pyridine, here we have this 4 nitrogen containing substrate. So we will discuss the mechanism first, then we will apply it up to our substrate. Okay. So here we have pyridine and we have sodium amide. Okay. So it will attack on NH2 minus nucleophile will attack on ortho position of pyridine, and this bond will get open up. Okay, so when this bond will get open up, negative charge will generate over here. So this is also known as a Meissner-Hammer complex. Okay, Meissner-Hammer complex formation will takes place here. So here we have two options, either path A or path B. We will discuss both path one by one. So when we have path A, that time what will happen, this lone pair of nitrogen will push here and deprotonation will take place. So in this case we will get imine type of intermediate where double bond will form over here. Then the H minus hydride ion will attack on this proton and it will abstract it by elimination of H2 to give the corresponding iminium ion intermediate. Okay. After getting this intermediate, now we know the negative charge is existing on this nitrogen. It will push over here and it will aromatize the ring, which is the stable form of the aromatic ring. Okay, so after the aromatization, the negative charge will generate over this exo nitrogen, which is outside the ring, and this nitrogen will further treated with the water in work up to take up the proton. So it will take the proton to give the corresponding 2 amino pyridine. Okay, so this is a path A. Now let's talk about the path B. So in path B, what will happen? Here we can see this negative charge will push first after getting this Michener complex. This negative charge will push electron over here and it will form aromatic ring here. Aromatization will take place. After the aromatization, hydride ion will abstract the proton and it will eliminate as H2 to give the common intermediate, and which will under workup condition further give the 2 amino pyridine. So path B looks more favorable to me. It's your own choice, because here aromatization is taking place, which is feel like a driving force here. Okay, so both the mechanisms are correct. The correct option is here. We will discuss on our substrate. Okay, first, so we know that here this NH2 will attack over here and we will get like this intermediate, correct? After this one, what's the next step? Wait. Okay, this one. So next one is this can push over here. Okay, so after get this one, H minus will take up the proton and it will become okay. So after this one, the next step is hydrolysis. So this is the product we will get here in Chichi-Babin reaction. So the product is option number this third. Okay, got it? So next, predict the major product of the following reaction. So this is the example of Smiles reaction. Let's talk about this one. On arrow we have DMF, DMPU, sodium hydride, heat, and in second step we have hydrolysis. Okay. So what is DMP? DMPU. Anyone? So DMPU is a organic reagent which is named as dimethyl tetrahydro pyrimidinone. So structure, talking about the structure, you can see here we have dimethyl tetrahydro pyrimidinone. So pyrimidinone means we have this both, right? And dimethyl here. So because tetrahydro is there, so there is no double bond. Like tetrahydrofuran, here this is tetrahydro pyrimidinone. Okay, pyrimidinone. So after getting the structure of this pyrimidinone, we are going to discuss the Smiles reaction. Okay. So sodium hydride is a base, all of you know that. So it will abstract the proton. So from where it will abstract the proton? So we know that in our case we have that proton here, right? So it can abstract the proton from here, like here ethoxide ion is abstracting the proton, here hydride ion will abstract the proton. It's a strong base, right? So proton abstraction will take place and we will get this as an intermediate where the negative charge is on nitrogen. Now this negative charge, which is become a nucleophile here, will attack on the electrophilic center of the molecule, right? And we'll get this type of intermediate. So here also we'll do it that way only. So here after the proton abstraction, negative charge will generate over here, which will attack on this center. So electrophilic center, right? So here we have sulfur, which can donate the lone pair here. Negative charge will come here. I'm writing the resonance structure. Sorry. So here we can see that we will get resonance structure where this center is electrophilic. Okay, so it will attack over here. after that one you draw by yourself this resonance structure and you will get here like this way. So it will form the intermediate which will look like this way. I will write here and H methyl groups okay. After getting this one, what will be the next step? This negative charge will push here and because here there is no heteroatom to get open up like this one, it will get stabilized. So aromatization will take place after pushing the negative charge. Okay, so deprotonation will take place to give the here corresponding product. Okay, so aromatization is taking place. So the correct answer is here. Option C. So the next question is predict the major product of the following reaction. So here we have Banol kind of system and here the name reaction is Bucharest reaction. So what happened in Bucharest reaction? First of all, here we have die system. We'll understand first on mono one, then we will apply it here. Okay, so we have here hydroxy naphthalene. Okay, we can say here alpha naphthol. And here we have banol. Okay, so have alpha naphthol is here, so protonation will take place as we have here acidic condition. Okay, so after the protonation we will get here this type of intermediate. So we will see both the path. This is the our starting material. So path A, first of all I will go with the path A. I will name this one as path B. So in path A we have protonated hydroxy group here. Then this bond will get broke and positive charge will generate over here. So this center is electrophilic. Right? So after this one we have here also in path B also this intermediate will generate. So this is the reversible one. So here you can see that when this bond is pushing here in acidic condition, this is going here, right? And positive charge will generate over here. right? This is a resonance structure. So if it is on alpha position, this is reversible. Sorry for the inconvenience. Due to the technical error, the recording was stopped in between. So again, I'm going to start the recording and session. So here we were discussing about the Becquerel reaction. Okay. So we have discussed here in Becquerel reaction, we have here naphthol system, and in naphthol system, we know that if the lone pair of oxygen atom will push here, the positive charge will come on this place. Okay, so these are the resonance structure of each other, all these. So if the positive charge is here, it will again reversible, and because these are resonance structures, so it will look like this one. But if it is on meta position like this one, after this one, what will happen? SO3 manase will trap this carbocation and will form the 3A intermediate. After getting this intermediate, the next thing is ketoenol tautomerization. Okay, so in ketoenol tautomerization, we'll get corresponding ketone followed by attack of amine on carbonyl center carbon atom, electrophilic center of carbonyl carbon. Okay, so after getting this sorry amine attack, we'll get the 4A intermediate, which is this one. So after getting this ion, the next is proton transfer, which will make the water group as a good living group. So this water elimination will take place to give the corresponding intermediate here. And this intermediate will further undergo imine formation by deprotonation to give the imine. Then this imine will further undergo aromatization to give the corresponding aromatic amine. So here we are getting the naphthyl amine as a product, right? Naphthyl amine. So talking about the question, here we have Banol system where we have two hydroxy group, but the condition was given here ammonia and this SO3 and H4 twice. So here we know that this is 1-1 equivalent is given here. We are considering it as a 1-1 equivalent. So only one hydroxy group will undergo reaction to become a amine. Okay. So the same procedure will followed here and will get here amine. But this amine will further subjected for this reaction condition. That time we will get the diamine moiety here. So that's why the correct option, by considering the 1-1 equivalent, the correct answer is here option number A. Okay, this one. So next one is predict the major product of the following reaction. So what's this reaction? You can see here the addition is taking place on double bond, right? And the addition of aromatic halide is taking place. So there is a one name reaction, coupling reaction, which giving the addition of on double bond. Which reaction it is? Heck reaction. Heck reaction. Okay. So this is the example of Heck reaction. The mechanism is given here. So as I told you, whenever we have this type of coupling reaction, we have to remember three steps. First is oxidative addition. Second is transmetallation. and third is reductive elimination. Got it? So we'll follow these steps here on also. So first of all, we have here palladium catalyst, which is in zero oxidation state start, right? This one. After this one, oxidative addition will takes place. I told you, remember first step is oxidative addition. So oxidative addition of this halo aryl group will takes place. Alkyl or aryl, whatever it is. So R is our attached moiety. Okay. So sorry, not here. Here. This is halo aryl group. Right? Halogen substituted aryl ring. So here oxidative addition will take place and we will get here this intermediate. So in this case, these two L are acetate ions and this R is pH. Okay, because the addition of pH iodide is benzene, iodobenzene is taking place. That's why it is here, right? So after getting this one, the next step is coordination insertion in this case. Okay, so transmetallation is also taking place, but here it is mentioned as coordination insertion. Okay, so after the coordination insertion, we'll get this type of intermediate. So in starting, palladium was in zero state. Now it is in plus two oxidation state, and here also it is in plus two oxidation state. After this one, the next one is beta hydride elimination here. Okay, so beta hydride elimination will takes place, which will give this as a intermediate. So after the elimination, it will knock out this moiety. Right? Beta hydride elimination will takes place. So here instead other coupling reaction reductive elimination is results in a product formation, but in Heck reaction the beta hydride elimination will takes place to give the corresponding product. So after the beta hydride elimination reaction we'll get this palladium complex intermediate. After now this one will again regenerated, right? So we have base here, that's why we are adding here base. Here we have potassium acetate. So base will abstract the proton and it will eliminate the halogen atom, which will again result in a regeneration of catalyst. So here we know that in this coordination insertion, after this one, beta hydride elimination is resulting in a product formation, which is where we can see the R group is getting inserted, right? So here also this R phenyl ring will get here coordinated, right? pH. So the correct answer here is option number 2. Okay, this one. We will get this one, right? So now let's move to the next question. Where here in this question it is asked to predict the major product of the following reaction. So here you can see that sodium nitrate is given on arrow and we have here acid HFHPF6. So this is the name reaction which is entitled as Bals-Schiemann reaction. Okay, Bals-Schiemann reaction. So in this case, what happened first? We have here aniline and nitrous acid. So here also we have nitrous acid, right? Hmm. So nitrous acid, this lone pair of nitrogen will attack on the nitrous acid and this will get open up and it will take up the proton to give the corresponding intermediate. So in this case, what happening? This nitrogen lone pair is attacking on nitrous acid and it is forming the intermediate which will look like this one only. It is becoming OH and this nitrogen is bonded with thiophene ring. Correct? this way. So after getting this intermediate, now I will explain here and you just try to solve by yourself by keeping this intermediate in your mind, or you can practice with this one also. Okay. So the lone pair of oxygen will take up the proton from here on nitrogen, or we can say in short, proton transfer. We have discussed this topic n number of times, proton transfer. So proton transfer will take place, which will make this water molecule a good living group and it will get eliminated. So hydrolysis will take place, which will give you the this intermediate. Okay. After getting this intermediate, again the proton transfer will takes place. Same step, and water elimination results in a formation of benzene diazonium salt. Now, after getting this diazonium salt, the next step is we have acid, right? Fluoroacid. Here also we have acid. So it will attack on the nitrogen atom of diazonium group, and it will give you a intermediate which will look like this one. So here what will happen? This F minus of from BF3, BF4, sorry, here we have HPF6, right? So fluorine attack will takes place and this diazonium elimination will takes place minus N2O, which will result in a formation of fluorobenzene. So fluoro substituted product we will get here. So instead of amine, functional group change is taking place and we are getting chloro here. So this type of reaction is known as a Bal-Shimon reaction. So you practice with this one and we will get here the product, which is the fourth one, correct option. Okay. Then next, predict the major product of the following reaction. So here we have acidic condition and water, right? So this name reaction is known as a Bamberger rearrangement. So this is the reaction of phenyl hydroxylamine with a strong acid to give the 4 amino phenols. So this reaction mechanism is given here. So we have here phenyl hydroxylamine, right? This is the tetramethyl substituted phenyl hydroxylamine. So we have acidic condition. So I told you whenever we have acidic condition, that time we have to do the protonation. Correct? So we'll do the protonation. So protonation can be done on two places, either on nitrogen or this oxygen. Correct? So here we have both the options. If the protonation will takes place on nitrogen like this way, and it will undergo proton transfer to give the this three intermediate. So and directly we can protonate the hydroxy group here. Okay, so we will get this intermediate. Ultimately, we'll get this intermediate. Then water elimination will takes place. Hydrolysis to give the corresponding intermediate, which will look like this. After getting this intermediate, now we know that it will these two are resonance structures, right? Resonance structures. So, because this group is having a para-directing group, so at para position, we have negative charge, right? Sorry, at para position, we have positive charge, right? So because on our ortho and para position, this positive charge is stabilized because of this nitrogen. That's why the electrophilic position, which is para 1, will get attacked by nucleophile. So what is a nucleophile? Water, right? We have water here as a nucleophile. So O minus, sorry, O minus, or I can write directly H2O, which will attack on this center. And we will get here this as a product after deprotonation. So here we can see that the para amino phenol is synthesized by this method. So here also we have para position here, because all or because ortho position is occupied here, only para product we will get here, only single product. So the correct answer is option number 4, because at para position we have alcohol, right? So from hydroxylamine to aminophenol, here we are getting. Okay. So next step. Next question is predict the major product of the following reaction. So don't get scared of the big structures. Just you have to find out the functional group where the reaction is going to happen. So here all we are observing this big molecule, but here we know this is the reactive center. So the reaction will take place on this one only. So we'll discuss the mechanism here. So this is the nucleophilic aromatic substitution reaction example. Here we know that we have here hydroxy group, right? So it will pull the electron here. Okay. Then after this one, this group will go here, this will here, and now this double bond will attack on this side. So simply the aromatic substitution is taking place here. So cyclization will happen, which will give the. So I will first make this way for your understanding. Okay. Here we have OM. Now aromatization will take place because aromatic rings are more stable to give the corresponding product. Okay. So here what is the correct answer? 6-member ring formation will take place. This A. Okay. So this is the nucleophilic aromatic substitution reaction. Next question. Predict the major product of the following reaction. So again, this is the Becquerel reaction. We have discussed the mechanism earlier. So instead of banol, now we have here naphthol. Okay. So in naphthol, first of all, we will get from naphthol. I have discussed this Becquerel reaction mechanism. So from naphthol, we will get here. Sorry. Yeah. Naphthylamine. Right? We will get here naphthylamine. After getting this naphthylamine, now we will get to know the other mechanism. How the other mechanism will take place here? Anyone? You can think about it. So this nitrogen lone pair will attack on this one, and it will get knocked out. So after getting the intermediate, which will look like this one, Sorry. Okay. Or we can write this way. Huh, this way. So if I will write the structure in open form, this one, it will look like this NH2 positive and H2, correct? So here this lone pair is attacking on this one to form the then proton transfer will take place. It will look like this way. Okay. So after this intermediate, everything will remain same. So we have here this intermediate. So this lone pair will push here. This will go like this. This one, this, and we'll get this intermediate. So again, the protonation will take place because deprotonation was happened in earlier steps. Okay, so protonation will take place where aromatization will takes place to form the corresponding 5-member ring. Then this 5-member ring will again undergo the deprotonation elimination reaction where this NH2 will get eliminated to give the corresponding 5-member ring. So here again the formation of 5-member ring will take place and we'll get this as a product. Okay. So this is the correct answer. So option number 3. The next question is predict the major product of the following reaction. Again, one more time, Heck reaction. We have discussed it. So here the given is palladium catalyst. So here in this case, we have only one substrate where halogen group is there, halogen atom, and double bond is also there. So this is a type of intramolecular molecular Heck reaction. Okay. So in this intramolecular Heck reaction, what will happen? The mechanism will remain as it is, same. So palladium 0 will start the reaction. So oxidative addition will take place. So oxidative addition, that means palladium insertion will take place in between here in this Cl and carbon. Right? After the oxidative addition, coordination insertion will take place. So here it will get coordinated. Okay. So after the coordination, now the palladium will become a +2 oxidation state. Then the hydride elimination will take place. Beta hydride elimination. So in beta hydride elimination, we'll get the cyclic ring. So here 1, 2, 3, 4, 5, 5 number ring along with the methyl at the this position. So from here to here it's taking place, ring formation. Okay. So after the beta hydride elimination, we'll observe the pi member ring formation. So the here the correct answer is option number two. So you practice this question by yourself because we have discussed this two times. Now I hope you are able to solve this question. So please try yourself. Okay. So next question is predict the major product of the following reaction. So here we have copper reagent. All of you can see here, right? So this is the Ullmann reaction type. So here we have two iodide, right? Two iodide. So in Ullmann coupling reactions, this will get cyclized. Okay. So we have discussed Ullmann reaction condition also. So oxidative addition will take place. So copper will get inserted in one of the iodide here, right? Like this. So after this one, we'll get the intermediate like this. Okay. Then the next step, the another halogen side is there, haloalkane group is there, which will further undergo oxidative addition with this copper. Now, on same copper atom, we have two groups, right? So in between we have copper. Suppose here halogen group, here this group, and one this whole group. Okay, this whole group like this. So after this one, reductive elimination will takes place where these here to here bond formation will takes place. So one, one, two, three, four, five, six, seven member will. So this seven member information will takes place and we will get the product here. So option number A is the correct answer here. Okay. So solve yourself. The next question is predict the major product of the following reaction. So here we have on arrow K2CO3, that is potassium carbonate, and microwave, right? 200 degrees Celsius. So this is the example of Smike's reaction. So here NMP is given. What is NMP? Anybody? So we know that in Smike's reaction we need a base where it is potassium carbonate. Here it is potassium carbonate. But the NMP is N-methyl 2-pyrrolidone. Pyrrolidone. Earlier also we have a DMPU, right? Here we have NMP. Both are similar, but the 5 member and 6 member difference is there. We have discussed, right? So the structure of NMP is N methyl. So methyl group is on N, right? N methyl to py pyrrolidone. Okay, pyrrolidone. So here we have smiley reaction. So base will abstract the proton from this NH2. So after the proton abstraction, here negative charge will generate. And then this negative charge will attack on this side, right? Sorry, here, this way. If I remember, ring formation will takes place like this. Okay. After this one, again, the negative charge will push back it will. So I will form that intermediate first. Correct? This way. Now after this one, This negative charge will push back and it will get open. And we will get here. Okay, this way. Now it will undergo a tautomerization or a protonation will take place and it will give you a this as a product. Understood the mechanism? So hope you understood and try to solve yourself. You will get more clarity. So the correct answer is option number 4. Okay. So the intermediate is cyclized intermediate, right? But the ring opening will takes place, which will give you the product. Okay. So the next question is predict the major product of the following reaction. Here you have on arrow copper sulfate and hydroxylamine and aqueous ammonia, ethanol and pyridine heat. So here we have the Stephen's Castro mechanism. So we have discussed this mechanism earlier also. So the reaction is believed to proceed via four-centered transition state. I already told you. So here again, first of all, copper will bind over here at this place. Okay, so we'll get this as a intermediate. So proton abstraction will take place first of all. Then copper will bind here, and we'll get this intermediate. Then after that, it will follow the same mechanism pathway which we have discussed earlier. Stephen's-Castro coupling reaction. So here we will get the alkylated product, disubstituted alkyne. So here this ring will get substituted here, this one. So we will get the alkyne product. First we'll get the hair product. I will write hair product. Here we have nitrogen, right? Alpha to the nitrogen. I should make it clear. This. Here we have hydroxyl. All of you are clear till here. So for this one, you just have to replace this with copper. Halogen, metal halogen exchange you have to do. Then after this one, you have to make this four center transition state and you will get disubstituted alkene here. After getting this alkene, I talk you about the endo-div hydroxylation reaction, right? So here we have oxygen, right? 1, 2, 3, 4, 5, right? 5. So here this moiety can undergo 5 endo-div 5 endo-div hydroalkoxylation reaction. Hydroalkoxylation reaction. So in this case, 5-member ring formation will take place. Where we have this way, like this movie. Then here with oxygen. This ring is attached, correct? And here double bond is coming. So this will get protonated and we will get here this one. So this is the product we are getting in this case. Because in second step we have pyridine. Pyridine will abstract proton from here and O manase will undergo attack here and undergo a pi-endodic hydroxylation reaction. So the correct answer here is option number A. Okay, solve by yourself. This will help you to understand the mechanism. Next question. Predict the major product of the following reaction. So here again we have basic condition, potassium amine, and the reaction will follow the benzene intermediate formation. So we have discussed in last class also benzene intermediate formation. So here you can see that here the proton abstraction will takes place, right? Here negative charge will generate if the proton abstraction will takes place, correct? After this one, this will push an chloride and will act as a leaving group to make it benzene intermediate. After this benzene intermediate, the base will again abstract the acidic proton. So more acidic proton is this one. So proton abstraction will take place. So negative charge will generate over here or ketoenol tautomerization will take place. So this will attack either on this center or this benzene intermediate, right? So here it will form this one because 6-member ring formation will take place if it will take place via this carbon. And here 7 members. So always 6 member is more stable and favorable. So it will happen this way, favorable part. And it will become like this. Okay. So here you can see the mechanism and this is the correct answer product. So the correct option is option number A. Okay. So I hope you understood this mechanism. So last one, two question we'll solve. So question number 8, predict the major product of the following reaction. So here we have copper powder, TMF, and temperature is 100 to 105. So this is the Ullmann reaction condition again because copper is given, copper powder, right? So metal halogen exchange we have to do. So we'll do here copper insertion, correct? So copper will undergo a oxidative addition reaction. So oxidative addition will take place and copper will inserted here like this. Okay. So after getting this intermediate, another moiety of this molecule will undergo oxidative addition with this copper. So now we will get copper with two intermediate. Sorry, with two attached alkyl group. Okay. Here also the same thing. Okay, this way. And here it is true. Got it? So metal halogen exchange is taking place in first case, then oxidative addition, and we are getting this one. Then after this one, reductive elimination will take place. So reductive elimination will leave us with this one. So these two are same. Okay. So the correct answer is option number. Next question is the last question. Predict the major product of the following reaction. So here, this is the Chichi-Babin reaction we have earlier discussed. So in this Chichi-Babin reaction, what happened first? So all of you know that the NH2 group will attack on ortho position here this way, and negative charge will generate on this part, nitrogen. And then aromatization will take place to give the corresponding alpha amino pyridine. Alpha amino pyridine will undergo again with the reaction with base. So base here we have used. So base will abstract the proton from here. This is the acylic phase, right? So after the proton deprotonation, hydrolysis will take place and results in a alpha amino pyridine product. So here the same thing will happen and we will get alpha amino group here. Okay. So after that getting this alpha amino product, this it will further undergo reaction with HNO2. So HNO2 will form this alpha amino group to corresponding ketone. So this is the homework for you. Go and solve yourself. If you are not getting the answer, we will discuss in the next. Okay. Thank you so much for your kind attention. In next class, we are going to discuss about the class 19 and 20. So week 10 class. Okay. So thank you so much for your attention. Now I'm closing the class here.